Welcome to the CEDA 20 years anniversary panel. Yeah, my name is Wang. I'm the coordinator of this panel, and also I'm the TPC chair of ASP-DAC 2025. And first of all, let me introduce the panelists of our panel. I think everybody knows these four great guys in our community. Professor Yao-Wen from National Taiwan University, and Professor Tim Cheng from Hong Kong UST, and Professor Shinji Kimura from Waseda University, and Professor Jeong-Taek from Sungkyunkwan University. Yeah, as the TPC chair of 2020 ASP-DAC 2025, I would like to express our great gratitude to IEEE CEDA for their generous support and sponsorship for this conference. And this event won't be successful without their commitment and also their great support. So let's thank the great support from IEEE CEDA. And for the lunch, right? Yeah, now it's my pleasure to invite the president of IEEE CEDA, Professor McGow, to the stage for the opening remarks. Let's welcome. Yeah.
Thank you very much. You're not here to listen to me, so I'll be extremely brief. IEEE Council on Electronic Design Automation, CEDA, is the home of everyone that is interested in design automation and design and the methodologies and the tools associated with electronic circuits and systems. And we're here to foster the work of everyone, researchers, academics, practitioners, by sponsoring conferences, by organizing workshops and meetings, and also supporting student chapters in their activities. So get in touch with us. And to end, I want to thank the organizers of ASP-DAC. 30th anniversary is always a very important moment for a conference. It means it's an established forum for everyone, not just in the area, because we can see that it's an international event. CEDA is only on its 20th anniversary, but we're doing our best to promote that ASP-DAC and all our other flagship conferences continue to have the highest level of technical quality and to interest all of our members. Thank you very much, and please enjoy the panel. Thank you.
Yeah, thank you very much for Miguel and for the inspiring words. And today we will welcome celebrating the 20th anniversary of CEDA. That is a milestone for this remarkable journey of EDA. And this panel is talking about the past, present, and the future of EDA. And we will try to have each of the panelists to speak for 3 minutes to share their thoughts about the past, present, and future of EDA. So let's start the talk. And the first one, we welcome Professor Yao-Wen. Yeah, please. I try to have the PowerPoint. This one. Okay, please.
Hi, good afternoon, everybody. As professors, we can talk on 10 slides for 3 minutes, and not Tim had only 1 slide, so I can take that for 3 minutes. Okay, yeah. So I will make my. Okay. Okay, thank you. So that's only 1 minute. Okay. I did this intentionally. Okay, yeah. Okay. Also, to explore the future direction of EDA, let's first look at the key drivers for our semiconductor industry. First, the AI, right? And high-performance computing, automobile electronics, and 5G 6G, IoT, cloud applications, big data analytics, and intelligent medicine. Actually, everything about computing. Yeah. So what we need to enable all these drivers that we need the semiconductor devices with higher performance, lower power, and a smaller area, such as a smaller cost, right? And in my opinion, we have the main direction to achieve the PPA goal. Yeah. The first is more with continuous scaling by using advanced transistor technologies, yeah, like CFET, EUV, backside power delivery, etc. Yeah. And second, beyond CMOS, with the new materials such as compound semiconductors, with the higher the electron mobility to improve the operating speed. Yeah. And the third direction, more and more with heterogeneous integrations to pack various of the components, the low-cost components, into a single package with the better the system PPA. So these are three main directions. Yeah. So for the more advanced technologies by continuous scaling, we typically look at the three aspects: the transistor patterning and also interconnect. For transistors, yeah, we have a FinFET, right? And Samsung already gets into the gate-all-around, and TSMC will be using nanoshift for 2 nanometer and beyond, and complementary phase is just ahead. And for patterning, currently we are using EUV lithography. Yeah. And for interconnect, now the backside power delivery and also the optical components already come into the pictures. Yeah. And for new materials, many on the compound semiconductors, for example, like gallium nitride, silicon carbide, they with the higher voltage, higher frequency, and higher temperature, and even radiation-resistant applications, such as the electrical vehicle, chargers, the data centers, power electronics, and the 5G, the satellite communications, etc. Okay, okay. So, so the economic advantage of more the getting the smaller and smaller. So this is why we are switching to the heterogeneous integration with us 3D stacking with a better the system PPA. Yeah. Okay. Advanced packaging becomes more and more important. For example, the TSMC, the successful stories about info package for cellular phone, and also the CoWAS for GPU servers. Yeah, I think everybody knows the current situations. Yeah, and to cope with the heterogeneous integration, before we can enjoy the ride, we need to consider the many additional aspect of challenges. Many on the multi-physical domains, including original traditional system, physical, electrical, and with new challenges on thermal, mechanical, and optical effects. And to achieve the goal, we really need to have a three-way closer collaboration among the EDA, design, and process, and also with the help of AI in the current stage. Yeah, for AI, we are talking about not only the AI help the EDA, I think that EDA and AI are complementary. Okay. Now, actually, I have a concrete example that the AI for EDA to help the processor, and also the EDA for AI for AI chip, etc. Okay. Yeah. So this to conclude my opening statement. The first one is I think that we have multiple approaches to achieve the PPA holy grail, and to achieve the ultimate PPA goal, we really need an ecosystem where multi-physical domains need to be considered, and EDA design process and AI co-works is essential. And I think in this regard, and CEDA and ASP-DAC and even our university can help. Yeah, together we can go far. I believe technology challenges will not limit our progress because the human imagination can always bring us to the endless frontiers. So I would like to cite the Einstein's inspiring quote. The human spirit must prevail over technology. Thank you. Yeah.
Yeah, thank you very much. Yeah, thank you, Yao-Wen. Yes. And next we will welcome Team Cheng. Yes, I will try to find the, I with the help of Apple Watch, I really have the timer on my, on my hand. So I think you have your own, this one? No, this one. Team, yes.
Yeah.
Yes, please.
All right. Well, given 3 minutes, so I gave a lot of thoughts on how we can convey the message shortly. But before I start, I'd really like to convey my congratulations to CEDA for the 20th anniversary, as well as the 30th anniversary for ASP-DAC. When I was invited for attending this event, I immediately say yes. I think I'm really glad and honored to be here and meet so many old friends. Some of us just been going through this 30 years. I think, Jason, I heard your talk. You were there for 30 years ago for the first conference. I was here and with CEDA. So I have only one slide. I want to talk about future. But talking about future, let's start with the trend. First is great news. Semiconductor, EDA, become a global technical focus. I talked to many friends in these 2 days. One thing is striking me. Professors say, I have too much money, I don't know how to spend, which was not the case 20 years ago. When electronics was considered as a mature area 20 years ago, this totally different atmosphere. Great news. However, we also see a very different era, deglobalization. My entire career was lived under the umbrella so-called globalization. Semiconductor is known as the most globalized industry because the supply chain ecosystem. Now everything flipped upside down. The third, I think among many technical areas, I think the biggest trend is AI, ubiquitous AI, ubiquitous application of AI changing our life. I think we don't need to talk about. So AI for medicine, AI for education, AI for everything. So what does that imply to CEDA? I think CEDA as a professional organization, we have our responsibility as well as opportunity. First is our area becomes so important. All country has CHIPS Act, so they have money to spend. But they want to put a wall outside their own region, their own country. We as a professional organization, we really need to stick our neck out, insisting on pre-competitive collaboration and exchanges. So I would really think this is opportunity for CEDA. We are a professional global organization. We can talk, we can exchange, we can really promote the benefits of humankind, which I think this is the biggest information, and I think we can have exchange program, we can run organizations, we can have internship, etc. Due to time limit, I'm not going to elaborate. Second is exploring CEDA academia industry collaboration model. I think there is another barrier between industry and academia in EDA. Professional society will be able to build programs together. I think there are many innovative ideas I have seen in AI development. Company working so close with industry, but we don't do that in electronics and EDA, and we can do that. Again, this topic can elaborate for 1 hour if you're interested in. Third is AI. I think we talk about exchanging with industry between different regions. I think AI is an area we increase our relevance. So there's a huge topic of AI for EDA, EDA for AI. We need to broaden our influence for recruitment purpose, for creating more impact to the industry. So I think this I summarize that under the umbrella of ubiquitous AI, EDA and the semiconductor in general should broaden our coverage, making greater impact. Thank you.
Yeah, thank you very much. Next, we'll welcome Professor Shinji Kimura, and I try to open the PowerPoint. Yeah, sorry about that. Yeah.
Just one page.
Yes, it's great.
Okay, I'm Shinji Kimura from Waseda University, and I might be the oldest person in the panelists. Okay? And 30 years before, I'm working on the variation diagrams or SAT procedures. And okay, that's the path. And please note that each topics might growing, but after 10 years, they are shrinking also. And at 1990, we say that's a paper explosion related to BDD. And recently, we have the AI applications. And but future, I'm not sure. So AI might also be shrinking in the near future. That is because past years, we also have the AI boom, but that is also shrinking. And but fortunate thing is that currently paper explosion and the large number of paper submissions we have obtained. And but the unfortunate thing is that if the paper becomes much more, then we should shrink your presentation time. Sorry for that. And the future, I do not know. And near future, we have the AI-related works, and photonic circuits might be have very good, and the quantum circuits also. And the future, EDA for new device should be considered. That is because silicon will not shrink anymore. And new applications of EDA algorithms are also should be considered for another areas, topics. That's my position. Okay.
That's great because Professor Shinji Kimura saved 1 minute. Yeah. Next, we will have Professor Kong. I think
I prepared too much. He gave me 2 more minutes. So
yeah, but actually, Professor Kong, I think he has the longest experience in the industry, right?
Yes.
Yeah, please.
It's a great honor to participate in this prestigious panel. I think our EDA industry has been growing together with conferences, especially ASP-DAC. Integrating AI ML into EDA is rapidly grow for several several years. Another one is growing design complexity and the large number of increased designs from families, system companies. So EDA was started based on a standard cell design methodology in 1980s. A lot of progress in EDA.AI. So mega trend is increasing role of EDA in DTCO and STCO. So scaling has been changed, as you mentioned previously, to design scaling and system scaling. So clearly, EDA is the core engine that enables DTCO and STCO. So EDA is reinforced by AI and machine learning. So as you can see, reinforcement learning can be seen as first wave of AI, and the generative AI is kind of a second wave of AI. So finally, evaluate evolution of AI for AI semiconductor is most important, and the expansion of design space exploration in many application areas such as AI, automotive. So AI is good for EDA, and the EDA is good for AI system chips. And chips of systems of chips I think that's my position, and it's prosperous for long time. That's my position. Thank you.
Okay, thank you, Professor Kong. Professor Kong is also very on time. I didn't show up the, yeah, yeah. So let's come to the discussions of the panel. Yes, actually, I prepare 3 questions here. Sorry, to find the questions. Yeah, because now I am the chair in Department of EE in Tsinghua University. Yeah, I see a lot of increase of the CS guys, including the recruiting the people and the others. So the first question I raise is about the talents. Then how to attract smart students to devote into the EDA area for the next 20 years. Because I see EDA is the hardest because you need very, very smart guys, and the salary maybe not be that high, but you need to learn a lot of, not only about the algorithm part, but you need to learn about the circuit part, right? So it's requires a lot, right? So the first question is about the talents, and second one is about the research. As it is already mentioned by Team Chang that for the industry and academia, how could we work together? Because if we don't work together, then we don't have the data. If we don't have the data, we cannot do any about the algorithm part. So it is also a very tough question I raise here. And third one is about the conference. Yeah, because we see that we see that U.S., China, and all the stuffs, but we are technical society, right? How we could communicate and how we could move, still keep the moving to push the limit of the technology. So the third one is about the conferences. So I just put it here, and I think that we still go for this way. And Yao-Wen, please, yeah.
Okay. We will need 2 hours sessions, starting with me, though.
Do you want
okay.
slides
Yeah.
or not?
Yeah. Okay. Yeah.
Yes.
Please. Yeah. Thank you. Yeah. Actually, I also have quite a few slides on the individual questions. Okay. For talent cultivation, I think the most important thing is not only the industry academia collaboration. What I want to stress is the 3-way. The next slide. I can control that.
Yes.
Okay. I want to stress on the 3-way the cross collaboration among the industry, the government, and also the academia. Yeah. For industry, of course, industry can provide the real data, right? And also the funding to academia and job opportunities, which are wonderful to our students. Yeah, the government provide the policy making and also provide the faculty and funding support. And for our academia, of course, our core value is to provide the core technologies. Yeah, and also for human cultivations. Yeah, human resource cultivation. Yeah. Okay. Yeah. Yes. Yeah. I think in this regard, not only the 3-way collaboration, I think as Miguel mentioned, CEDA can help in many ways. Yeah. For example, for CEDA, we provide many kind of services, conferences, awards, and publications, activities, etc. Yeah. CEDA can really nurse the EDA talents and promote the EDA activities to help our academia, also industry, yeah, at the global stage. That's very important to link all the people in the world all together. And of course, one of our main mission is for talent cultivation. Currently, we probably focus more on the young professionals and also the minorities, like women in engineers, and also some related programs. Yeah, and for EDA talent cultivation, I think, in my opinion, why not? Why not join EDA area? There are so many advantages. I just give 3 main points. Okay, the first one is EDA is really cool and critical, right? Why is it cool? Now our background is mathematics, the algorithm and optimizations. With this kind of training, they can keep us from the aging problem. I value the EDA very most when I talking to students. When I always give my deep service, and my students provide the research, the innovations. Okay, this kind of complementary collaborations. Yeah, and it's very critical. Look at the political issues currently. Yeah, it becomes the next choking weapon. During this for geopolitics, yeah. And the second point I would like to stress is that the EDA can help create sciences and technology to advance our human civilization innovation, yeah. And through EDA, we can change the world and make our dream come true while receiving very good pay. Let me show you the statistic from Bloomberg. Yeah, here this the 15 top 15 high-paid companies in the U.S. Well, you can see the third one is Cadence, even ranked higher than Google. Yeah. Yeah, so don't worry about the AI area. The money talks, okay? Yeah, and the synopsis rank at the top. So I think that's very important to attract real issue to attract the top talents in the EDA area, okay? Yeah, and as I mentioned earlier, the EDA and AI are complementary for talent calibration. Yeah, I already published this, so maybe I just skip it. Yeah. Okay. Yeah, and the last one is sorry. Probably take this chance to give some suggestion to our young generation. I'm not senior enough that team. Okay. Yeah. But I have so many points. Basically, I have 3 main points. Yeah, no pens, no games. Okay, and the second point is the mindset. I call it the mindset trinity. And the third is pay attention to our EDA fundamentals. But with each point, I have 3 subtopics. Well, no patience, no games. Always keep our biggest passion with integrity, curiosity, and flexibility. Okay, yeah. And for mindset, the trinity is I would say the attitude. Attitude is a big thing. It's a really I would say a really important thing. We say that the attitude determines the altitude. Yeah, yeah. The second one is the dreaming and the goal setting. We need to keep our goal with the determination and also execution plans. And the third part is the appreciation. For most of our achievements, I believe is due to some joint work. So we need to show our appreciation to our team members. Yeah, and the last part is we have to pay attention to our EDA fundamentals because EDA students and engineers that must cultivate sufficient background in mathematics, algorithm, and optimizations. Yeah, to enjoy the endless frontier. Thank you.
All right, so I'm the next. Am I? All right. I don't have any slides, so let me start from the conference, the third topic. Some advertisement. Next year, ASP-DAC will be held in Hong Kong, and in Hong Kong Disneyland. You don't need to apply visa. Pretty much for almost all countries, you can enter Hong Kong without visa. And not only in Disneyland, you will be able to see the Victoria Harbor, very vibrant city. So with all this, first inviting all of you, writing papers and coming to ASP-DAC next year in Hong Kong. But I'd like to stress that based on my position in the opening statement, that deglobalization does cause challenges. And I think running conferences will be an area that CEDA can really pay greater attention. And I don't suggest that we really need volunteers to go to different areas. But however, university industry can be bound together through the professional society, and different regions university can be bounded through the professional society. And we run events called CEDA events and find volunteers in different regions, inviting people based on the professional society's platform for exchanges. And we, the senior one with white hairs, all know that academic exchanges, exchange with industry, is so fundamental for any research area. And that is also an attraction to young talents to enter the discipline to develop their career. So I really hope that to Peach, we think hard how we will be able to encourage international exchanges, partnership, collaboration with compliance to all regions' law, while being able to promote activities. I think that's, in my personal opinion, will be the most important and great opportunity for professional society in the current climate. And secondly, research. Maybe I talk about talent recruitment. For young generation, the most important thing is their career path. Will I be able to develop a long career in this area? Will I pay well? I think for Long Bean, I found that selling to kids to say our area is very hard, requires stress and attention, devotion. To be honest, it doesn't go very well, because young generation really want to have a good work-life balance, being paid well, have a long career path. The good news is, I think the tide has been turned. If you those remember 10 years ago, for just between E and CS, 99% of students enter CS, 1% enter EE for those programs which we're familiar with. But now the tide switch. A lot of CS subjects which was hot is no longer as hot. And as I mentioned, the global focus in our area become critical. So I would say the tide is with us, but we cannot relax. I share with you my personal experience. In the early 90s, control is very cold. Chemical engineering was very cold. If you recall, those who are senior enough. And they're scratching their head why they lost to ECE, why they lost to other discipline. Then what chemical engineering captured the field, biomedical, in the engineering field. Control is pervasive. Even today, machine learning, control has a very strong presence. So we, EDA, has to think that if we narrowly define just high-level synthesis, verification, layout, I think we will not go far. Design automation is so broad. Any design can be automated. And the electronics can be so broad. So we really need, as a community, to pitch, to do the PR. What is the future for young talents? Even me as a parent, if I do the test, should I put my kids in EDA moving forward? When they ask me for advice. And I can tell you 10 years ago, many EDA professors don't advise their kids to get into EDA. Am I right? But now it's not anymore. EDA has a bright future, but PR is our weakness. So CEDA can play a very, very critical role in imaging. I'm not talking about nitty-gritty because there's so much in the technical field. It's very difficult to get into details. But I think we as a community need to pitch very well. And another example is computer vision. Computer vision's growth from CVPR 20 years ago, 500 people, to today, 10,000 people. Their growth, we need to learn from it. And we have the opportunity. I think EDA has the opportunity to face 2,000 people conference to 10,000 people conference if we do it right. And finally, research. I think industry academic collaboration is the must. We, for PhD training, so much about research, so little about internship, connection to industry. Likewise, industry always come to university, can you send my students? But I don't want to tell you what they want to do. So this kind of barrier has been there for 20, 30 years. But if you learn from other fields, which I happen to have the opportunity, if you look at AI, they have, like Microsoft Research Asia, they have 25 years under Microsoft leadership. They always take students for internship. And through that channel, they work with universities very closely throughout the PhD study. And that creates excitement. That creates a vehicle for recruitment. And we need to learn from it. So I would say all the big players should provide internship for PhD students, for graduate students. And that kind of mechanism has to be massive everywhere. And if we can have that, it's a wonderful opportunity. Last point, innovation and incubation. Once again, EDA startup is alive again. There was, I think, in my generation, after 2010, they slowed it down because of the trend. But in the past 5, 10 years, we see startup emerging in EDA, which is wonderful, wonderful news. How we leverage that? Because young generation, if you ask to raise their hands, who want to go to big company? Who want to go to startup, want to become professor? The answer 10 years ago is very, very different from today. So being able to develop a career for innovation and entrepreneurship is a must for any field. So EDA, because of the startup opportunity, I think this is, again, opportunity for us for recruitment, right? So how to leverage these several channels, all the trend, the wave coming our way, we need to have a professional organization to coordinate and have a strategic development so that all this can be happening, leveraging resources from academic, industry, and government. So I'll stop here. Thank you.
Yeah, thank you, Tim. Actually, I'm an alumni of Microsoft Research Asia, and also if you guys want to do a startup in EDA, comes to me. I will try to find some money for you.
Okay.
Talent, research, and the communication.
Okay. And for the talent in Japan, Japan is very special. That is because 7 or 8 years before, almost all semiconductor companies do not exist, shrinking. And but good news is recently, the government would like to invest again for semiconductor industries, and then students would like to join our laboratories for making finding the job. And job opportunity is very important in Japan. And but okay, one problem is LSI has been developed at 65 years before. So after developing, then the EDA also starting, okay, and design technologies has been developed, and so very long history we have on EDA area, and we should learn about long histories, and recent smart students wouldn't like to learn about such long histories, and so I usually say that if we learn about the old things, then we can apply to new things, and that is because we have different situations in all days. So that is good ideas to think about all things. And so we are, okay, professors should think about that to gather new talents, but that is also including some financial support to pay the traveling fee to the conferences. Also, so yeah, industry collaboration is very important, we think, and research. Currently, industry academia collaboration is not so good in my feeling. That is because in Japan, especially, that is because they do not want to support students, not so much. That is because almost all industry students, industry person, do not take the doctor's degree in Japan. And so they think that the doctor's degree is not so important. That's a problem. But we are thinking that if the number of doctor students going to industry becomes larger, then we can improve the situation in Japan also. And the third one about the conference, I'm the steering committee chair of this ASP-DAC, and we would like to continue this kind of the very good good conferences for discussing each other like this way, and sponsor IEEE CEDA. I would like to continue to support this kind of the conferences. That's a issue of the conferences, and we steering committee also work hard to continue this kind of the events. That's all. Thank you.
It's very typical position. A lot of good things have been discussed already. But I have some point on growing talent. I think we need to teach EDA as well as AI together, because a lot of people prefer to work on AI, but EDA is closely coupled with AI technology. So attract young talent to the AI-driven EDA world with career growth, opportunity, and competitive compensation. As you mentioned, like Cadence and Synopsys paid as good as Google. So developing culture is also important to attract the young generation, as big tech such as Google did in the beginning. So we need to create those kind of culture continuously for satisfying water bill. And providing an internship, not only for master or PhD degree, to undergraduate students is very rare, but it's important for them to know EDA area as early as possible. And creating an ecosystem with more EDA startups and good investment and support from CEDA and industry, and good exit from the startups to get them more and to attract many more talent. And for feminist company and the EDA company are popular in United States, and now it's growing in China. I think establishing EDA research centers in university is very important. That's proportional to the prosperity of EDA and design companies. And in Korea, we recently established semiconductor specialized university project in Korea, and we are pretty much emphasizing EDA industry. So I think those types of special program is important to attract young talent. That's my position.
So do you guys have some other want to talk about these three? Yeah, because some of you pick one of them. Yeah. Yeah, sure. Okay, then I think it's time for our audience because we have limited time now. We have about 10 to 15 minutes to have audience. Yeah, please.
So for conference, I think generally speaking, in EDA conference, we don't have enough number of papers from industry, and we don't have enough number of attendance from industry as well. So if any of you agree with me, what do you think is the reason and how we can do better to get more industry contributions?
I think we have to have some specialized, more number of specialized industry session, as you did in other conferences such as DAC. And we can have also shorter session to increase number of conferences. So interacting with the industry, showing their success instead of writing a lot of detailed algorithms, demonstrating their possibility and sharing their status is very, very important. So please try to increase total number of specialized sessions associated with industry success stories. I think that's important, and shorten like a short presentation as done in DAC, so we can increase the number of talks from industry instead of writing long 6 pages. What about 1 page or 2 pages done in IDM? So then IDM ISCC had shorter pages, so more industry people can participate. That's my opinion.
Okay, in Japan, as I mentioned, 12 years before, we have 250 people are attending from Japan. But this year, we just have 120 or so. So the reduced part is corresponding from the industries. And we would like to increase attendees from the industries. We have the designers forum, but that doesn't work well at present. And short papers we are thinking about. And if possible, we would like to introduce and attract industry people to communicate academia and industries. So, but it is rather hard. Okay, so one reason is that in Japan, very few EDA companies exist. So attendees from the EDA companies is not so expected, especially only Cadence or something we have. So that's a problem.
I think if you look at other conferences, a big conference, Semicon, DesignCon, there are a huge number of presentation papers in our field. So my observation is somehow for some of the conference, the selection criteria is too much either too so-called academic. Some other conference is so industrial. I share my personal experience. I spent good part of my career in test community. I still remember in ITC, if you talk to industrial people, they all say, oh, the academic papers are useless. You talk to academic people, they say the industry papers has no contents. It's all ideas. But that reflecting how different part of the sectors view things. So the solution is industry academic collaboration. And this happened in the AI field, for example. You see a lot of top-notch papers in the AI field, vision, language. It's joint between academic and the industry. If EDA or in general electronics area, we really can establish that very low barrier collaboration between these two. The paper come out will be high quality, welcoming to both community, and this present also great attraction to talents coming into our field. That linked to what I said before. So I think we need to reflect ourselves why the community couldn't grow. What are the fundamental issues? Especially in our ASP-DAC, I think good fraction are academic. how to plug ourselves into industry, I think is a very, very important efforts that we need to work together to penetrate.
Okay. Yeah, Yao-Wen. Yeah, please.
I think the main issue, the main problem is lies in the culture issue in our area. For example, sorry, I don't want to brand any company, but for example, for Synopsys, we don't see the papers from Synopsys. Why? They have their own internal conferences. Their engineers, their researchers have already submit their papers to their internal conferences, then submitting to that DAC, ICCAD, because once they release their technologies, then it's related to the value, the business, the issues, the value they can create. Unfortunately, that's quite different from the AI area. Yeah, I think that's the main issue. Actually, don't worry about our EDA contributions. As I can see from the Taiwan industry, the EDA has tremendous impact on the design services, the foundry, the chip design companies, and also EDA companies. Yeah. For example, I witnessed the EDA division and the TSMC. The 20 years ago, about like 1,000 people. Now it's grown to more than 2,000 people. Why? Because they need more advanced technologies, which really need the EDA's help. EDA is really essential in this regard. Yeah. And another business issue is unfortunate that for our EDA, we are talking about the whole design flow. The whole design need probably hundreds of EDA tools. Unfortunately, that will make our startup very difficult. I have my own experience that we started up a company in 2015, which was acquired by Synopsys the last year. This is the second time that we really commercialized our placement tools. Yeah. But what we did is just the point tool. Yeah. Without the strategic support from big company or the government, I think the easiest way for our academic people to start companies to work on some point tool, squeezing the technology, make sure your technology is a bit the state of the art, bit the synapse cadence. As I show you with the AI empowered the technology, but we can improve the chip design of MediaTek's most advanced chip, Dimensity 9300 series, which really outperform the Qualcomm's the state-of-the-art chips with the help of the new tool and also the AI technologies. Yes. So don't worry, but we need to look at what we are good at. We're good at. Yeah. Okay.
Yeah. Any other questions? Yes. Yeah, please. He raised first.
Thank you. So to attract or to educate more EDA talents, people have been discussing about establishing EDA major. So it's a new major different from CS or EE. So what's your opinion? And if you think it's necessary, what's the difference? We need to do from the current education system. Thank you.
Okay, I think this question I asked the team to, as the vice president of Hong Kong.
I just expressed my personal view. The background is I believe undergraduate major should be broad, fundamental, and it has exposure to many things which are fundamental for their long career of 30 years. With that background, I personally don't believe EDA deserves to have a major. Just like robotics itself, I don't believe it deserves an undergraduate major for that reason. Because once you're too much focused think about after 4 years, if they want to do something else, do they have the background knowledge, skill set, etc.? And with that background, I even believe for engineering students, they need to have more liberal art education. The reason is the future has to be human-centric. A lot of our debate is engineering education doesn't have enough liberal art education so that there are almost this stereotyping thing about what an engineer look like. So I just want to express my view. Undergraduate major should be broad, fundamental, but graduate education, I think definitely EDA could be more than deserving a very focused education.
Okay, please, next question.
So I have a potentially peripheral question, and maybe you can answer whether it's related to these three topics. Would EDA benefit from its own roadmap, and would CEDA, should CEDA take a role, or is it just a waste of time, too much effort and waste of time?
Yeah, please. Yes.
If no one else, I don't want to. I think research community pretty much is bottom up, grassroots. I don't think there would be a meaningful roadmap. Who should organize? CEDA is a collection of volunteers, already representative enough. So it's more practical matter. It's just even like running a university, but it's my job as well. I constantly ask that, should I have a strategic roadmap for university research? At the end, even that is not quite feasible because your university defined based on who you hire. What are their strengths? And based on that, you can develop roadmap. So those people will be the one defining the roadmap. Would CEDA being able to coordinate for certain specific topic? Yes. But CEDA being able to give the community a roadmap, I think it's just a very tall order. I don't know who can do it. Maybe Wang Yu and Jason, you can lead that.
You want Jason?
Okay, first I want to say this is a great panel and touched a very important issue. I think among all these, the talent acquisition is probably the most important one. Is that how do we sustain the pipeline? That I will encourage that everyone think deeply that how do we address this issue. Personally, I don't feel it's a problem because every year I just doing the graduate student admission. We got like 30, 40, 50 applications specifically asking me to be the first choice advisor. So these students obviously interested in EDA, but I think at the bigger scale, there's a real problem that how do we sustain the pipeline? I think we are not doing a very good job in introducing our undergraduate students for them to know about EDA. I think we are all passionate about the teaching our specialty classes, right? The physical design, logic, synthesis. But we need some introductory course to get a student interested into that topic. I can share one experience is that I teach a regular CS class, parallel distributed computing, but I want to get them interested in hardware design. So I add a component, also customized computing. In 2 weeks, using high-level synthesis technology we developed, with some customization, they can develop a CNN accelerator running in the FPGA cluster in the Amazon cloud. Okay, so all our project are done in Amazon cloud, but the FPGA is also done in Amazon cloud together with the GPU. The parallel computing obviously has the GPU as well. So if you just stop at the GPU, that's it. They are the typical CS course. But if you go one step further to introduce the FPGA design component, then they really appreciate the circuit design and the design automation. The only reason they can do it in 2 weeks with a CNN accelerator is because of the tools we developed, right? And so maybe CEDA can take a role. I'm sure there are other successful examples to develop this successful component that we can add on to our existing courses to just make an effort. I think look at the distinguished panelists. It's all coming from major universities. I think if all of us can actually do a better job to get 10%, 20%, 30% of our students interested, then I think we'll probably have a better time to recruit students in the future. And this will, and by the way, the students is now our biggest asset. That's how we can bargain with industry, right? So, do you want to work with us or not? Do you want our students or not? So that's the kind of a strength we'll speak from.
Okay, then one last question. We are a little bit behind, but yeah.
So, talking about the attracting the younger student, how do you think about the pre-college education in this period? Maybe the team's answer will be we don't need because you are talking about the generic education should be much better for undergraduate. But how do you think about pre-college people interest in this field? Because the AI are doing that, robotics are doing that, and so on and so forth. So
pre-college.
So I want to echo all the audience opinions that the talent cultivation is the most important things. Yeah. Okay. And then CEDA can help. And being a past president of CEDA, I have to report to Miguel, the current president now. So I have to say something, otherwise I'll get branded by Miguel. Right? I think CEDA played a good platform to invite all the experts from the different domains to work together. For example, we have ITI's technology roadmap formed by academia and industry, and then even for heterogeneous integration, starting 2015, they also have HI heterogeneous integration roadmap. Yeah, I think with the help of CEDA under the leadership of Miguel, I believe CEDA can do more than CEDA already have done many things on talent cultivations. For example, the CAD contest, yeah, the PhD forums, yeah, and all kind of educational programs. But CEDA really need more volunteers, and especially from the young generation. Yeah, that's mentioned by Jason, the pipeline. Yeah, yeah. Okay. Yeah. And for education, sorry, I'm old school guy, right? I would rather focus more on fundamental issues, the algorithms, the data structures, the linear algebras, etc. Otherwise, we probably need 300 credit hours to graduate with an undergraduate program with the heterogeneous integration. We also need to care about the mechanical issue, optical issues, the thermal, everything, right? It's simply impossible. But I would like to focus more on the problem-solving training for our students. Which need all these fundamental courses to get their interest in this area. Now, once they are in this area, the operator can explore the more advanced courses to handle their research problem. Yeah.
Can you have 30 minutes, 30
Yes,
seconds?
Since Geda Sensei was saying I may not agree, actually I fully agree. The pre-college education. Yes. We do have academy to run camps that for students to run use a circuit board to some experiment. So we really need to approach high school kids for electronics, for this competition, but from the angle to generate interest rather than very comprehensive, they have to know all the knowledge. Because I believe if they're interested in, they come in to study and they will find their way. So I fully agree pre-college advertisement approaching all kinds of camp competition will be the right way to do it.
Okay, so I think time is very limited, so let's thank all the panelists for giving this wonderful panel. Yeah. And we also thank ASP-DAC 2025's steering committee and also CEDA for giving us this wonderful opportunity. Thank you very much for all you guys to participate in this panels. Thank you. That ends the panel, right?